So let us prove the next problem, that is example 9. Prove that square root of 3 is irrational. Okay. So in the last class we have proved square root of 2 is irrational. Similar way we are going to prove the next one, that is square root of 3 is irrational. Okay. So what we are going to do, first we are going to assume that square root of 3 is rational. Okay, we are going to prove by using the proof by contradiction. Okay, we are just proving by contradiction. Then we'll get the statement is false and we can say that square root of 3 is irrational. Okay, so proof. Let us assume to the contrary that square root of 3 is rational. Okay, I told you, right, we are going to prove by contradiction. So we are assuming, that means we are thinking that or imagining that the square root of 3 is rational. Okay, then the next step is we are going to take that square root of 3. If it is rational, that can be represented in the form of p by q. Okay, either you can write square root of 3 is equal to p by q, otherwise you can write it as square root of 3 is equal to a by b, anything. Okay, so I'm going to take it as this is equal to a by b. Okay, so that is, we can find integers a and b where this b will not be equal to 0. Okay, b should not be equal to 0 such that square root of 3 can be written as a by b. Okay, now the next step, you are going to take a is equal to the remaining value. Okay, so how can you write this? You can rewrite it as b root 3 is equal to a, which can be written as a is equal to b root 3. Okay, so we have got one value for a as a is equal to b root 3. Then what is the next step? We need to square it on both sides. Okay, so squaring on both sides, what will be the result? A you are going to square. So a square is equal to, this is b square, square root of 3. If you square that, you will get 3. So a square is equal to 3b square. Okay, so we got a square is equal to 3b square. From this, you can say clearly that a square is divisible by 3. Right? From this equation 1, if you take this as equation 1, from this you can say that, therefore, what can you say from this? A square is divisible by 3. Right? See, just if you take this, a square is equal to 3b square. This is in the form of multiplication. So 3, if you bring it here, it will be division. So a square by 3 is equal to b square. See, 3 divides a square. That is what we can get from this equation, right? So if 3 divides a square, then definitely this 3 will divide a also, right? If 3 divides a square, then definitely 3. If 3 can divide a square, then definitely 3 can divide a, right? So that is the thing which we can get from this. Okay, so in the next step you are going to write, so that we have learned already in the last theorem, right? In theorem 3 we have learned already that, so if a square, if p divides a square, then p divides a, right? That is the theorem we have learned already, right? So if in the last video it is there, so if p divides a square, then p divides a. Same way here, if 3 divides a square, then 3 divides a, right? So you can write, by theorem 3, it follows that a is also divisible by 3. Okay, So the next step, what you're going to do, if you're dividing, you'll get a quotient value, right? So you're going to take that as a square. A is equal to 3c. If you are just dividing like this, you'll be getting a c value, right? In the last problem also we had done the same way. So I'm going to take that as c. Okay, so a, here I have written, right, this will be equal to one particular value. I'm going to take it as c. Okay, so let a by 3 is equal to c. Okay, so if you are going to take it like this, so what will be the next step? You can take a is equal to, so a is equal to 3c, right? Now what is the next step? You need to substitute this a value in this equation 1. Okay, so substitute. So we are substituting this a is equal to 3c in equation 1. So what is the first equation? A square equal to 3b square. So instead of a, what you should do? You should write 3c. Okay, so 3c the whole square is equal to 3b square. Okay, so 3c square is 9c square is equal to 3b square. Now from this you need to find what is b square. Okay, so 9c square by 3 is equal to b square. Now if you cancel this, you will get 3c square is equal to b square. That means b square is equal to 3c square. Okay, so from this you can say very clearly that b square is divisible by 3. Therefore, b is also divisible by 3. Right? From these two things, what can we conclude? Actually, we have assumed that a and b are co-prime. Okay, so a and b are co-prime. That means it will not have a common factor other than 1. But here we are getting a contradiction as a and b is having a common factor other than 1, that is 3. Right? Just like the last problem by proving square root of 2 is irrational. Just like that, we have to assume that this a and b is co-prime. Okay, by assuming that, we have started the procedure, and here we are not able to prove that, right? Because we are saying that this is not co-prime because it is having a common factor other than 1, that is 3. Okay, so here we are saying that b square is equal to 3c square. Therefore, b square is divisible by 3. Okay, therefore b is also divisible by 3. Okay, so from this we can say a and b is having at least 3 as a common factor other than 1, right? So therefore a and b have at least one factor, at least 3 as a common factor, right? So this contradicts the fact, but this contradicts the fact that a and b are co-prime, right? We have assumed that a and b are co-prime. So b is also divisible by 3. Therefore, a and b have at least 3 as a common factor, right? But this contradicts the fact that a and b are co-prime, right? A and b are actually co-prime, but here this is contradicting because we are getting a common factor other than 1, that is 3, right? So this contradiction has arisen because of our incorrect assumption that square root of 3 is rational, right? Because we started or we began the proof by saying that square root of 3 is rational, right? We have begun the proof by saying that we are assuming that square root of 3 is rational. Because we have started the assumption as a wrong statement, we are getting the here the result as a and b are not co-prime, right? We are not getting a and b as co-prime, right? So this happened because of an incorrect assumption that square root of 3 is rational. So actually, what is the truth? The actual proof is we can conclude by saying that square root of 3 is irrational. Okay, so how we have to prove this? I'll explain once more. So first thing, we have to prove what square root of 3 is rational. Okay. So let us assume to the contrary that square root of 3 is rational. Whatever number they are giving you, okay, square root of a particular number, if they are asking you to prove it as irrational, first thing what you have to do is you are going to prove by using the proof by contradiction. Okay. You have to prove by contradicting that. So you are assuming something. Okay. You assume the opposite of the statement, that is square root of 3 is irrational. Opposite of that is it is rational. Okay. So if it is rational, that can be written by P by Q. Right. A rational number can be written in the form of P by Q, where Q is not equal to 0. The same thing I have done here using integers A and B, where B is not equal to 0. Then one more thing we have to keep in mind, that is we have to, suppose that A and B have a common factor other than 1, then we can divide by the common factor, this by the common factor. So assume that A and B are co-prime. The most important thing is you have to mention that we are taking integers A and B where B is not equal to 0, and you are assuming that A and B are co-prime. That is important. Okay, you are taking this A and B as co-prime numbers. Okay, that means it is not having common factors other than 1. Then square root of 3 is A by B. Okay, this is the form of a rational number. Now you need to find what is A. So you are multiplying this B here. So B root 3 is equal to A. So A is equal to B root 3. The next step is square it on both sides. Okay, if you square that, you will get it as A square is equal to B square into 3, because square root of 3, if you square that, square root of 3 into square root of 3 is 3. Okay, so A square is equal to 3B square. Now we got an equation, right? By saying this, A square is divisible by 3. Okay, we can write it as A square by 3 is equal to B square, right? So A square is divisible by 3. If A square is divisible by 3, by theorem 3, we can say that A is also divisible by 3. Okay, then let A by 3. If you divide that A and 3, you will get a quotient value as C here. Okay, if you are dividing any rational number, you will be getting a result like this, right? So A by 3 is equal to C, then A is equal to 3C. Now we got a value for A. Substitute this A value in this equation. So you will be getting it as 3C the whole square is equal to 3B square. Square it. So what you will get here, 9C square is equal to 3B square. Then you need to find what is B square. You got here what is A square, right? Just like that, you need to find what is B square. So B square is 9C square by 3. Right? So if you cancel 3 and 9, you will get 3 here. So 3C square is equal to B square. So B square is equal to 3C square. So just like A square equal to 3B square, you got B square equal to 3C square. So here you can say B square is divisible by 3. Then B is also divisible by 3. This we are saying from the theorem 3. Right? Then here we are getting that A and B are not co-prime, because we have a common factor other than 1, that is 3 here. So it is wrong, because we started saying A and B are co-prime, but here we are getting it is not co-prime. So this happened because of the incorrect assumption that square root of 3 is rational. So actually what is square root of 3 then? It is irrational. So already you have learned this in class 9th. Okay. So here I have a rational number as well as an irrational number. Right. Sum of a rational number and irrational number will be always an irrational number. Okay. Same way, difference of an rational number and an irrational number will be irrational number. Same way, product of a rational number with an irrational number will be an irrational number. Same way, if we take the quotient, if you are dividing a rational number with an irrational number, the result will be a rational number. Okay. So based on this, we are going to prove some problems. Okay. Okay. So here we have a problem. Show that 5 minus square root of 3 is irrational. Right. 5 minus root 3 is irrational. We need to solve it. We need to show that 5 minus square root of 3 is irrational. So what we are going to do? We are going to take the contrary by saying that 5 minus square root of 3 is rational. Okay. So we are using proof by contradiction. So let us assume to the contrary. Let us assume to the contrary that 5 minus root 3 is rational. Okay, we are taking it as rational number. So just like the last problem, what we are doing, this will be a rational number. That means it can be written as a by b, right? 5 minus square root of 3 is equal to a by b, where a and b are integers and b is not equal to 0, and we are assuming that a and b are co-prime numbers. Okay, the same way, just like the last problem. So we are writing here, that is, we can find co-prime A and B where B is not equal to 0, such that you are writing this. Why you are taking like this? It is a co-prime and A and B. Why we are taking? Because we have said that this is a rational number. We assume that 5 minus root 3 is a rational number. So, if it is a rational number, it can be written by A by B, and B is not equal to 0. And we are assuming again that we can find a co-prime number A and B, right? What we are taking here, that integers are co-prime. So, such that 5 minus root 3 is equal to A by B. Okay, now just like the last problem, what you are going to do here, you are going to rearrange this equation and you need to find what is root 3 from this. Okay, you are going to rearrange this to get what is square root of 3. Okay, so if you rearrange this, what you will get? 5 minus a by b is equal to square root of 3. That means square root of 3 is equal to 5 minus a by b. So this can be again written as square root of 3 is equal to, if you multiply this here with b, with 5b minus a by b, right? Just making it as a like fraction. Okay, so multiply numerator and denominator with b. Okay, that's all. So you got square root of 3 is equal to 5b minus a by b. So by seeing this, you know a and b are integers, right? You know very clearly by seeing this, since we have taken integers, right? Since a and b are integers, okay, we get 5 minus a by b is a rational number, right? 5 minus a by b will be a rational number, right? We get 5 minus a by b is a rational number, which implies from this what you can say, 5b minus a by b is also a rational number, right? You know a by b is a rational number, right? Listen carefully. You know what a by b is a rational number. Then 5 minus a by b is a rational number. Then 5b minus a by b is also a rational number, right? 5b minus a by b is rational. Okay. So 5b minus a by b is rational. Therefore, from this what can you say? Square root of 3 is also rational, right? Therefore, square root of 3 is also rational, right? But this contradicts the fact that square root of 3 is irrational. But actually we know very clearly from the last theorem, we have learned very clearly that square root of 3 is irrational, right? So actually this contradicts, right? This contradicts the fact, okay, that is a fact actually, that a fact that square root of 3 is irrational. Okay, so this contradiction has arisen because of an incorrect assumption that 5 minus root 3 is rational. Actually it is an irrational number. Therefore 5 minus root 3 is irrational. Okay, so actually what we are doing here, we are going to take the opposite of the statement, that is we are going to prove by using contradiction. So 5 minus root 3 is a rational number. You think like that, you are assuming, okay? Then you are taking a co-prime numbers a and b, and since it is a rational number, 5 minus root 3 is equal to a by b. From this you are taking what is square root of 3. Okay, since, listen carefully, since this a by b is a rational number, okay, 5 minus a by b is a rational number, then 5b minus a by b is rational, that means root 3 is also rational. But this contradicts the fact that square root of 3 is irrational. Where we got this? Actually we got from the theorem which we proved in the which we proved at last. Okay, from that we got very clearly the square root of 3 is irrational. Okay, so actually this contradicts the statement what we got right now. So this contradicts the fact that square root of 3 is irrational. This contradiction is arisen because of an incorrect assumption that 5 minus root 3 is rational. Actually, that is an irrational number. Okay, so we conclude that 5 minus root 3 is irrational. So the next question is, show that 3 square root of 2, okay, 3 root 2 is irrational. Okay, so what we have to do, just like the last problem, we are going to take the contrary. We are going to assume that the given number is an rational number. Okay, it is a rational number, like that you are going to assume it. Okay, so let us assume to the contrary that 3 root 2 is rational, right? You are going to take it as a rational number. Then what is the next step? You are going to find a co-prime A and B where B is not equal to 0, right? That is, we can find co-prime A and B where this B is not equal to 0 such that such that 3 root 2 is equal to a by b. Okay, now from this what you need to do, you need to rearrange this so that you will be getting what is square root of 2. So square root of 2 is equal to a by 3b, right? You will get like this. Now by seeing this, you know a is an integer, b is an integer, 3 is also an integer, right? From that you can say a by 3b is a rational number. If this is a rational number, that is equal to square root of 2. So this is also a rational number. But actually whether it is true? No. That is contradicting, right? Because we have already proved that square root of 2 is an irrational number, right? So from this, since a, b and 3 are integers, a by 3b is rational. Okay, you know a by b is rational, because of that a by 3b is also rational, right? I'll write here one more step. Since a, b and 3 are integers, a by b is rational, then a by 3b is rational, right? And so square root of 2 is rational, right? And so square root of 2 is also rational. But this contradicts the fact that square root of 2 is irrational. Okay, square root of 2 is irrational. So from this what we can conclude? So we can conclude that 3 root 2 is irrational. Okay, so we have proved it. So what is the thing? They have given you 3 root 2 is irrational, right? So we are going to take the contrary and we will be proving it. Okay, so we are taking the contrary that, let us assume to the contrary that 3 root 2 is rational. Then we are taking the co-prime numbers, that is a and b. Okay, we are taking two integers a and b where b is not equal to 0 and they are co-prime. So 3 root 2 is equal to a by b. From this root 2 is equal to 3, if you take here it is division. So a by 3b. From this a, b and 3, all these are integers, so that a by b is a rational number. So if a by b is rational, a by 3b is also rational. If a by 3b is rational, that is equal to root 2. So this root 2 is also rational. But this is contradicting the fact. Okay, actually we have proved one thing already, that is square root of 2 is irrational. So this statement is contradicting the fact that square root of 2 is irrational. So from this we can conclude clearly that 3 root 2 is irrational.